All right, so this is intelligent GUI automation with Sikuli. It's important. The intelligent part is important. You'll see why here in a little bit. This is just a description. It's from Meetup. You probably already read it. This is me. My name's Dominic. That's my Twitter handle and my email address if you want to get a hold of me. If you don't write those down, you can Google for my name. I'm pretty sure there's only one of me so far. So let's just jump straight into it. So first off, you have to understand what automation is. And I think everybody has a pretty good understanding of what automation is. I copied and pasted the Wikipedia definition there, and then I put in our probably more common definition. Automation is just making stuff do stuff for you. And that's what we're going to learn today. So there are different levels of automation. Level 0 is no automation, and the system is observing and maybe giving you feedback, maybe generating warnings or information about what's going on. Level 1, and by the way, these are kind of arbitrary. There might be some academic definition of the levels of automation that are slightly different than this, so don't write this down. Level 1 would be the system, the agent presents options to the pilot. So it detects things in the environment and it presents the pilot with choices, and the pilot just chooses from a menu. Level 2 would be the agent makes the decision but waits for confirmation from the pilot. So it says, hey, I'm going to do this. All you got to do is click OK. Then the third level is what you probably think of as regular automation or autopilot, where the agent is actually doing the actions without input from the pilot. And then of course, level 4 is Skynet. So what are some examples of automation that exist today in the computing world for graphical user interfaces? There are systems like AutoHotkey, AutoIt, and Selenium. These are different from Sikuli in one important way. AutoHotkey and AutoIt, those are ways that you can automate the keyboard and mouse. You can write a program and it can type for you, and it can move the mouse and click for you, and it's cool. Selenium is a way that you can automate web pages. So you give Selenium a website, you tell it to look for certain elements in the website and to perform operations on those elements. What's different about Sikuli, though, is that Sikuli works on anything. It works using computer vision. So it can actually detect elements on the screen, and you can use those screen elements to perform logic within your automation. So with all of the rest of these, well, maybe not Selenium, but with AutoHotkey and AutoIt, it's always going to do the same thing. I mean, you could put some logic in there, but the logic's not going to be based on what's on the screen. Selenium, I think you can extract information from the DOM tree in a web page, but then you're limited to just web pages. Sikuli, you can detect anything that's on the screen, and it can operate on any program. Cool. So how does it work? Sikuli uses computer vision. Specifically, it uses OpenCV, if you're familiar with that. If you're not, definitely recommend you get on YouTube and search for some OpenCV demos. It's really cool stuff. But it's basically an open source library that's used for identifying objects in an image. And they combine that. Sikuli combines OpenCV with Java, the Java robot, to do automation. It uses Jython, which is a Python implementation. It's a Java implementation of Python. So basically, that means that you write your code in Python, but you have access to the entire Java API, which is cool if you like Java. It's less cool if you don't like Java. And because it's Python, you have access to all the Python modules as well. Sikuli also has an integrated development environment. They call it a what you see is what you script environment. And it's also capable of doing OCR. This is through Tesseract, if you're familiar with that. And again, like I mentioned earlier, it can perform this computer vision on anything that appears on your screen. So if you're running a virtual machine, it can see that. If you have a VNC set up and you're connected to your phone, it can see that. If you're running an emulator, it can see that. Anything that's on your screen, that's what it can see. So I have a couple of demos here of Sikuli in action. So this first one, I should have started. This first one is actually a video that I made, and I'll describe kind of what's going on here. This is the front-end interface to the back end of an electronic medical record system. And my task at this hospital was they have all of these tests that they do in the radiology department, things like shoulder x-ray and elbow x-ray and wrist x-ray and left and versus right and bilateral and chest x-ray, and then you know, all the other modalities as well. So they have these hundreds and hundreds and hundreds of tests, and each of these tests have different codes. So when somebody orders that test, it goes out through the network with a special code that identifies it as this test. And they have different codes that identify that same test on different systems. Now, the problem with the particular system that we were using, this is called Sorient Clinicals from the Siemens Corporation. The problem is that there's no batch operations on it. Once you load the stuff into the system, the only way that you can modify things is by modifying the tests one by one. And there's no API for it. So it's very cumbersome and it's very prone to errors because the codes have to hand keyed. I have a text file that just has a list of all of the identifiers for each radiology exam and a list of all of the new codes that need to be attached to them. And then I wrote a Sikuli script that reads that file and then performs all of the necessary operations for each one of those things. So we'll watch one from the start here. See, if I timed it, I would have been like, right here is one starting. Let me just skip a little bit. Right about somewhere. There we go. Okay, so the first thing it's going to do, it has to, we missed it. It has to search for the correct exam, and then you have to double click on it. Enter doesn't work. You have to double click. And then you have to select the hospital. You have to double click again. And then it happened really fast there, but it actually clicked on a tab at the bottom half. Oh, maybe I should full screen this. Come on now. It clicked on this interface tab, which wasn't here before. It was over here somewhere. So it clicked on that interface tab, and then it clicked on this drop down, and it selected the result interface. This is going to send a code whenever they finish an exam. And then it clicked on that button there. It selects the outgoing system, types in the radiology code, marks it as an outbound interface, and then clicks the arrow to move it over into the list, and then starts processing the next code for this system. And then the next code. And then when it's finished with that one, it clicks OK, moves on to the next one and searches for it. Now, being the scientist that I am, I timed this against myself, and it's not actually faster than me. Now, I'm probably faster than the average person that's doing this, so it probably would be faster than the average person. But here's the kicker. I would run this in a virtual machine. And then I would run a second instance in another virtual machine processing the second half of the list. And then I would run a third instance in a third virtual machine processing a completely separate list. And then I would go home for the day, and it would do all of my work for me. And it would do it without making any typos, which I'll admit, I'd sometimes make typos. And it worked for free. So here's another example. Basically, what this program is going to do, it's going to set the IP address on a Mac machine. So it opened the network interfaces there. It's opening the correct one. It's going to change the setting to manual, and it's going to type in a static IP and the subnet mask. And that's it. It's brilliant, right? It's cool. You can do that. We have the technology.
I have a question.
Yeah.
What happens when like it opens a screen and it's like offset a little bit? I mean,
that's the really nice thing about Sikuli versus some of the other options. With the other options, you have to rely on all of the elements being in the exact right spot because you have to tell it exactly where to click. When you're using Sikuli, you can tell it to find something. You could, for example, you could say find the start menu and then click 38 pixels to the right of the start menu. It's pretty cool. Okay, here's a fun example. This is somebody who wrote a Sikuli program to automate an online roulette game. So you can see it there. It's making the bets for him, and it's constantly betting on red, I guess. I don't know how roulette works. Here's another example. Somebody wrote a simple Sikuli script to play Bejeweled. So, yeah. I'd like to see what's the one that people, the Candy Crush? Candy Crush? Yeah, maybe we should try that later. Maybe not. So those are some examples. Some of the other things you can do with Sikuli, you can do test automation with it, especially if you're doing a lot of heavy GUI work. It would probably make sense for that. And if you're a Java developer, Sikuli comes with JUnit packaged with it, and I don't actually use that, so I don't know how it works. But if you know what that means, then have fun with it. And then they also have this thing called Sikuli Slides. And the website for that is slides.sikuli.org. But basically what these are a way for you to create Sikuli scripts without actually writing code. So if you don't know Python and you don't care for Java, you can actually write Sikuli programs without writing a single line of code. I have an example here. Oh, I didn't mean to click. I meant to middle click. That's okay. I have an example here, and basically the way that it works, I'm gonna pause it. You make a PowerPoint presentation. You can also use Google Slides to create these presentations. You embed screenshots into your presentations, and then you draw shapes you add text and shapes onto the presentation to tell Sikuli what to do. So you add a text box and you type in a Sikuli command, and then you draw a shape that tells Sikuli where to perform that command. So we'll see this guy do it here. He's going to add a text box there, and he's going to type something. It's not going fast enough for me. He told it he wants Sikuli to do a drag and drop, and then he's going to draw a shape to tell Sikuli where to start that operation. And this is just PowerPoint. And then he's going to add another shape to tell it where he wants that operation to stop. And then he has to connect those two things since they're part of the same action. And then he's going to save his presentation. And then he's going to close it, and he's going to run the presentation as if it were a program. There are no special plugins that you have installed that you have to install for PowerPoint. You just make a PowerPoint presentation and you load it in the Sikuli Slides program. You can see that the Sikuli Slides program highlights the area that it's going to perform the action on, and there it goes. It just dragged and dropped that thing from the desktop into the recycle bin. I didn't actually know about Sikuli Slides until I did this presentation. So I haven't actually used it for anything, but it seems like it could be really cool. So let me go back to my presentation. Okay. Okay, so now I want to do a live demo for you guys. And in true brave fashion here, I haven't actually practiced this, and I'm not entirely sure what I'm going to do, but we're gonna try something. So this is a WordPress site that I use for one of the classes that I teach. And this is it's WordPress, which WordPress actually has a pretty decent API. And because it's in a web browser, you might want to use Selenium instead. But because I know Sikuli already, that's what I'm going to use. So maybe I'll look at my list of users here. And maybe I want to write a script that will edit every user and change them from an author to an editor. Sound good? Should we try it? All right. So the first thing I'm going to do is I'm going to fire up the Sikuli IDE. So I have it installed on my machine. I just made a typo. And it looks like this. Isn't it pretty? Let me start a new thing. It's written in Java, so it's very Java-esque, and I apologize for that. But you'll see you can do some cool stuff with it. So the first thing that I'm going to do with my program is I'm going to save it. Word of warning, I have had some stability issues with the IDE, with it crashing when I don't really need it to. So save frequently, of course. And I'm going to put that on that side of the screen so maybe we can see both of these at the same time. All right. And I'm going to zoom out just a little bit here. So I'm going to go back to my user list. And the first thing that I want Sikuli to do is I wanted to find all of the users that's in this view. So what I'm going to have it do, I'm going to have it identify users according to the text that says author here. I'm going to have it find everywhere where it says author. So I'm going to tell Sikuli to find all, and then in parentheses, I'm going to attach a screenshot. So to do that, I'm going to click on this take screenshot button. And when I do, the window, the IDE goes away and it lets me see my full screen and it kind of goes dark. And now what I'm going to do is I'm going to highlight the section that I want it to match. So I want it to match the word author. Yes. So you can see there, my image actually shows up in my editor. And that's what they meant when they call it a what you see is what you script. So you actually see the images while you're programming. So I'm gonna store that in a list. And then I'm going to iterate through that list. So it's actually not a list. It's an iterator. So while matches.has next. And I have to confess, it's been probably 5 years since I've actually used Sikuli before preparing this presentation. So apologies if I make some errors in the code and I have to look something up while we're doing this. I'm sure you'll get over it. So I told it to get the next match, and what I wanted to do is I wanted to click on the username. And what I can do is I can tell it to just click on the match. But when it does that, it's going to click right on the center of the match. But I don't want it to click right on the center of the match. I want it to click on the username, which is a little bit to the left of what I searched for, right? So what I'm going to do is I'm going to click on this button. And it's going to find everything on the screen that matches that. It's going to give me this little dialog. It's going to give me a matching preview, and it tells me right there, these are all of the things that match what I was searching for. And I can kind of tweak the sensitivity down here so I can, make it exact if I want. You can see there, well, that clearly doesn't work. Yeah, one thing to keep in mind is that Sikuli uses OpenCV, and OpenCV, it's not a pixel perfect algorithm. The way that it matches, it's looking for shapes and patterns. So if you set it up to 1.0, it is supposed to do pixel perfect matching. But if you don't, it's going to use its computer vision algorithms. So sometimes you want to match something that's yellow and it'll match something that's green. That's because it's color agnostic when it's not doing pixel perfect matching. Anyway, so I can use that slider to change the sensitivity. And then in the target offset tab, I can actually change where the offset is. So I'm going to scroll down so that it zooms out a little bit. And I want it to click right here. So I'm just going to click. Actually, do I want it to click there? Do I even know? What do I want it? Yeah, right? No, I want it to click way over here. Yeah. So I got to zoom way out. And I want it to click right there. So I just clicked there. And you can see the little crosshair moved over and it tells me, okay, that's negative 265 pixels in the X and 24 pixels in the Y relative to whatever match it found. So I'll click OK there. And so now it's going to click on that user's name. And then once it clicks on the user's name, it's going to bring up this. And what I wanted to do is I wanted to find the role box. So I'm going to have it find that. And I'm just going to tell it, just go ahead and click on that. So click on, whoops. I'm going to tell it to find this. I'm going to be kind of lazy. And you can see there, it gives you the little red crosshair to tell you where the center is. So if I have it click right there, I don't want to get the user's first name in there because not everybody's first name is Alec. But everybody should be an author, right? Because that's what I matched on. I matched on author, so I should only be clicking on authors. Okay, so it's going to click on that drop down. And of course, when you click on a drop down, you're presented with a list And then the next thing that I probably wanted to do is I wanted to click on the thing that I want it to be. So I'm going to tell it to click on editor. Now, the way that I would actually do this is I wouldn't actually give it the mouse command to match the text editor and to click on that. And the only real reason for that, well, partially because the computer vision isn't 100% reliable, but also because it's a little bit slower. It's faster for the computer and for people to just arrow down if you know exactly the number of spots you need to go. Also, you can, in most drop downs and most toolkits, you can just type. So I'm actually just going to tell it to type editor. And the really nice thing about this is that if for some reason it was somebody that was a subscriber and I was trying to change like all users to editors, if I just use the arrow keys and I always told it to arrow down 3 times, well, if that was set to subscriber, they would then be set to administrator. That would be bad news. Alex's not actually here today, so that's good. If I type editor, it doesn't matter where it currently is in the list. It goes straight to editor. So I'm going to tell it to do that. I'm going to tell it to type editor. And then the next thing I wanted to do is I wanted to scroll down to the bottom of the page. So to do that, I'm going to have it click. I'm going to have it click on this blank area over here. And then I'm going to tell it to press the end key so that it goes to the bottom of the page. So let me go back up. I'll tell it to click on some blank part of the page. And no, I don't like that. I'm going to do that again. I'm going to tell it to click right there. It should be nice and blank and unique. And then I'm going to tell it to go to the end of the page. So key.end. And then when it does that, it'll be scrolled to the bottom, and I'm going to tell it to click on that update user button. Do I really want it to do this? Sure, why not?
I want to know if you want to play with this after the presentation, which I know Dom is encouraging. If you have your laptop, I would encourage you to go and download OpenCV and start building it now, because it's taking quite a while.
If you're on Debian, I have Sikuli in my repositories. Okay. So I don't know what you guys run, but you might check to see if your repository has it already. You won't have to build it from source. Yeah, if you have to build OpenCV from source, you probably should have started 2 days ago.
I'm at 61%, so it's going all right.
Assuming it compiles without error.
Yeah, right.
I've compiled OpenCV before, and it wasn't a positive experience for me. Okay, so we have this program here. Let's see what happens when I click on the update user. I need to see what happens. I'm going to set him back to an author. What happens when I click update user? Does it take me back to the user list, or does it take me? It takes me back to his page. So I need to tell the program to actually. Oh, it went away. Oh, did you see that? I'll do it again for anybody who missed it. They give me a nice link at the top of the page that says go back to edit users. But if I'm too slow, it vanishes. So I don't want to rely on that because I'm not confident that this is going to execute fast enough to catch that thing. So I know that I can get back to my user list just by clicking on that little dude. Okay, pretty straightforward. Now, before I actually run this, does anybody have any predictions of what issues I might run into? Yes, way in the back.
How does it know when you go back and go on the next match? This can be on the next one.
So when I do this find all, it's finding all of the matches right now.
Right. But I mean, like when you scroll down on like the WordPress.
Uh-huh.
I don't know. Then at the end of the operation, you click user to take back to the top.
Yeah, I wasn't gonna actually worry about the second half of the page.
That was gonna be my question. It'll just see all the authors on this view, right? It won't actually search the entire.
Yeah, it only sees what's on your monitor. So that's a blessing and a curse, I guess.
I have a question if the update process finishes before it actually clicks the user icon.
Bingo. So yeah, so I'm telling the program to click on this update user button, and then I'm telling it to click on this the list of users. And the potential issue there is that the request may not have completed before it actually finds and clicks on the dude. So I want to make sure that that doesn't happen. So I'm going to tell the program before I tell it to click on the list of users, I know that when I finish editing a user, it's going to take me back to the top of the page. So I'm going to tell it to wait until, because when I click on save, right, I see the bottom of the page. And then when it's done saving, I see the top of the page. So I'm going to tell it to wait until it sees the top of the page before it goes back to the list of users. So the function for that is called wait. And you can supply it with a screenshot. So I'm going to tell it to wait for, for this right here. Looks good. Wait until you see that. And you can specify a timeout here so that if you don't want it to wait for more than 30 seconds, you can type that in. And I think that if it doesn't find it within the time limit, it actually throws an exception that you may or may not want to catch. I'm going to not catch it so that if it fails, then the whole program stops, because I want it to, like, you know, not go crazy and completely destroy my WordPress site. But this page may take a little while to load, so maybe I'll give it a 5-second, 10-second timeout before I click on that thing. Now, any other guesses on anything else that might go wrong?
You have a flash message there, the one that disappeared.
Oh, yeah.
Yeah, that's part of your screen.
Which one?
Your last screen.
After
the message will appear in like regular screenshot.
That's okay.
It'll revert to the original page. As long as it can see the text that's in the screenshot, it doesn't matter if it's in the same position.
Yeah, but I think the message is going to go in the way for you. So it
So it's sure where it's accordion.
That's okay.
Just wait till-
All that this says is it says wait until you see this. It doesn't care where it sees it. It doesn't care if it moves. It just, is that thing on the screen? Is it? Oh, it is on the screen. Okay, then we're done. We can stop. This is a blocking call. All it does is block until this appears on the screen.
Now, if the entire page of WordPress fits on the monitor, it's going to instantly click this instance out. Right? Like if you had a really small monitor.
Oh, right. Yes. Yeah. Thankfully, I'm writing this program for my computer, so I don't have to worry about that. That's actually a good segue to another point, though. You can save Sikuli scripts as a single file. So right now, this is going to save it in a directory with my code and all of my images in that same directory. You can export an executable, which basically just creates a zip file and puts everything inside of it. But then you can give that one file to somebody, and if they have Sikuli installed, then they can run your Sikuli script without having to, like, extract stuff and worry about images. So it's kind of like a program. They even call it export executable, but it's not actually like a native executable. You can't double click it. They do. It's an X-cuttable. I stand corrected. Sikuli, by the way, is open source software. So if you would like to support the cause.
You should submit a core.
Okay, so I think what we have might work. Let's find out. So I'm gonna go back to my list of users, and I'm gonna tell it to run. So I'm gonna save before I tell it to run, and then I'm just gonna hit the run button. Let's see what happens. It failed right away. Oh, so it's not get next. I'm looking at the bottom of the screen there. It tells me that Finder has no attribute called get next. So maybe it's just maybe it's just next. Oh, that's highlighted. That seems like it's probably right. All right, look, it clicked on a thing. It did the thing, and then it's going to click on the button, and then it's going to wait until it sees that thing at the top. It hasn't seen it yet, hasn't seen it yet, hasn't seen it yet. Now it sees it, clicks on the list of users. Oh, there's an error. Okay, so same mistake that we caught beforehand, but we didn't catch it this time. By the way, when you're using the IDE, if you want to stop the script, it's Alt-Shift-C. It's very important to remember. Okay, so that happened after I clicked on the user list, but before the user list was loaded. So I need to wait. After I click on the user list, I need to wait here until the user list is loaded. So actually what I'm going to do here, I'm going to take this, this image that I found earlier, and I'm going to put that in a variable, edit user top. And I'm going to use that variable here. And I'm going to tell it here to wait until that thing vanishes. Okay, so should we try it again?
Did it skip to the third?
Well, okay, so that's another important thing. When you use the find all method, and actually when you use any find method, if there are multiple matches on the screen, the match that it pulls is not guaranteed to be in any type of order. So it will process all of the ones that it found, but not top to bottom. Probably not. Maybe top to bottom if you're lucky in a weird way. Okay, let's try it again. Okay, so started on that dude. Set him to an editor, clicked on the blank space, update the user, wait until it sees the thing, which that thing has to disappear. Okay, and then it clicks on the user list, and now it's going to wait for that thing to disappear before it clicks on the next match.
No, it did not.
And there we go. Now I can go, I don't know, I don't drink coffee, so I wouldn't make a pot of coffee. But popcorn, yeah, maybe without butter though. There we go. I'm automating WordPress. Oh, there's an error there. Oh, and I didn't actually cancel it. It failed before I could cancel it. So what happened there? Find failed, cannot find. So anytime that you perform a find, you execute the find function. If it doesn't find what you're searching for, by default, it throws an exception. So you would want to handle that exception, according to the program that you're using. If you're not sure, just have it die, because it's better for it to die probably than for it to do a bunch of stuff you don't want it to do. Okay, so I need to make a note to myself that I need to go back and change everybody later.
Just change your script.
You're right.
I'll just fix the breather.
Okay, so that's a live demo. Now when I first started using Sikuli, the editor is really nice for doing things like seeing your pictures and doing the matches, so you can kind of tweak the sensitivity and the offsets is pretty nice. But the editor itself is a little bit clunky. If you're not a fan of it, which I'm really not a fan of it, you can use Sikuli outside of this IDE. They make packages that you can install on Eclipse and NetBeans, or you can just use it from the command line. So I'm going to close this, and we're going to go to the next example is Minesweeper. So I have some code here. Minesweeper.py, and I have a website. Minesweeperonline.com. It's a real website. And you can see there it looks just like the Windows Minesweeper. So, whoops. So I have my program over here, and what this program doesn't actually play Minesweeper. This program just observes Minesweeper. So I'll explain what it does in a little bit. I want to just show what it does first, and then you'll have no questions about it. So actually, let me go up a directory. So I have a Sikuli installed on my machine, and I can tell it to run. Let me do this first. So right now I have these 3 folders, and inside those folders is the code. So if I go into the Minesweeper folder, you'll see that I have some images there and then a Python script, and my battery is fully charged, which is always good. I'm going to go up a directory. I'm going to run the Sikuli command, and I'm going to give it that whole directory, minesweeper.sikuli. Now, the startup is a little slow. Most of that is because it's loading Java, the entire Java virtual machine. And I'll show you a trick that you can do that you can use to save yourself some of that time. Okay, so I believe it's running. I should have had to print a message to say that it's ready, but we'll just assume that it's ready. I'm going to click on a spot here. And I need to make my thing smaller so everything fits. Oh, that was terrible. I'm gonna add something here to have it just tell me. Oh, it's supposed to print the thing. And let me pull this down so we can see both at the same time. Basically, what I wrote this program to do is I wrote it so that it would find all of the numbers inside the game screen. The first thing it does is it finds the smiley face, and then it identifies the game area by going down like 13 pixels or something, and then expanding horizontally 256 pixels and expanding vertically some other number. I don't know. Oh, right there, 480 and 300. Look at that, it's right there on the thing. Okay, so it did its first detection. It didn't see any numbers at all. I'm gonna click on the thing, and hopefully it sees new numbers here in a second. There we go. So you can see there, it actually detected my thing. And if I click on another area, what? I'm actually like really good at this. Anyway, so one of the a couple of things that I wanted to point out in the code, the way that this program is working. A lot of extra functions here, but the first thing that that I wanted to show you is this code here. Can I? Maybe if I do this, there we go. This line here, the onChange method. So basically, what this does is you give it the first argument is like a sensitivity, and then the second argument is a callback. So you tell it. You provide it an area on the screen, you tell it to watch this area, and if it changes, call this function. And then I tell it to observe. There's a number of different callbacks that you can attach to. This one's just looking at on change. So, and then observe actually tells it to start looking for those changes and to call the callbacks when they occur. So the area changed is right here. So when area changed is called, it loads the board and it prints the board. So what does loading the board look like? Well, it's right here. Basically, I have a list of patterns that are numbered 0 through 5. Now, there's more potential. There's up to 8 in Minesweeper, but I didn't bother to generate the scenario where I could actually capture those pictures. So it wouldn't find 6, 7, and 8, but it would find 0 through 5. So it looks for that pattern. And what you'll notice here is I'm using, there's a pattern class. I give it the name of the file. So I have a file called 0.png, 1.png, 2.png. And I'm changing the sensitivity by using the similar function on that pattern object. So I want it to match with a 95% confidence level. If I wanted to match exactly, then I could use the exact function for that. 95% is good enough though. That gives me a list of matches, and I iterate through the list of matches. And I do some math. All of the squares are 16 by 16, so I'm just dividing by 16 to calculate its logical position. Yes?
We're still on that. Line 21.
Thanks. So the mine area is the area that I calculated by first finding the smiley and then moving down and expanding the area. So the match is, when you get a match, the match is giving you those coordinates in screen coordinates. Not region coordinate. So I'm just subtracting the X there to make that a relative coordinate, and then dividing by 16 to convert it from its pixel coordinate to its logical coordinate in the grid. But yeah, that's it. That's all that program really does. It's pretty simple, but it's really impressive to watch, right? And it wouldn't be difficult to tell it to click on specific areas if you knew what kind of logic to follow for it to do that. Okay, next example, last example. I need this over here. That's enough of that. Okay, so this is a game called Dr. Mario. Is anybody here who's not familiar with this game? One person, 2 people. Okay, so just real quick, this is the game. Mario, Dr. Mario, I haven't seen his credentials. The object of this game is to eliminate all of the viruses. You do it by stacking similarly colored pills above, below, or beside that particular virus. So I'm gonna put this yellow here, then put another yellow there, and you'll see that virus goes away. And I'm winning the game, hooray. So that's how Dr. Mario works. Conceptually, pretty simple. It's a lot of fun. This is basically my childhood right here. I'm bringing you guys into my inner circle. So what I want to do is I want to write a program. Maybe I eventually want to write a program that can play Dr. Mario. But before it can play Dr. Mario, it has to be capable of understanding Dr. Mario. So I have a program here, and we can go over the code if you guys want to. This is also on my devICT account, which I'll give you a link for here in a little bit. But I'll just run it, and then maybe I'll explain what it's doing as it runs. It's not perfect. Oh, and while it's doing that, I'll show you also what you can do so that when you're doing your programming, you don't have to fire up the Java virtual machine every time. So what I'm going to do here, I'm going to go into the Dr. Mario folder, and I'm going to run Sikuli in interactive mode. So I give it the -i flag. And when I do that, it's going to load the Java virtual machine. And then it's going to also load some of the OpenCV support libraries. So there we go. It's ready to go. I can do whatever I want now. It's Python. So one of the things you can do in Python is you can tell it to execute a file. In this case, the file that I wanted to execute is called drmario.py. That has my Dr. Mario code in it. And when that Python file finishes executing, I'll be back in the interactive shell. So I don't have to wait for it to fire up the Java virtual machine again. So that's handy. It's not actually going to work for this example because I'm using this observe thing, which sort of runs on a separate thread. And so it runs indefinitely until you send it a kill signal, which kills the entire Sikuli. So not the greatest example, but now you have it in your tool belt. So let me fire that up here. I've paused my emulator there, so it's not doing anything. It tells me it's ready. Well, it was really fast. Okay. So what the program's going to do, I'm going to unpause it, and we should see that the emulator will repause it as soon as that first pill starts to drop. And actually, I'm going to do something real quick. I'm going to cancel that, and I'm going to start this over because this is a really bad layout for me. Reset. Thanks. Whoop. Okay, it is on slow. Okay, so I'm just going to let that pill go down to the bottom, and I'm going to pause it there, and I'll fire this back up. Okay, he says he's ready. Let's see if he's ready. I don't know. I was working on this right before this thing, so we'll see if it actually works. Mario throws a pill. It pauses the game. It detects the pill. Then it checks for all of the viruses inside the bottle. Once it identifies all of the viruses, then it calculates what it thinks is the best possible move, and it performs that move. Mario throws a new pill. It pauses the emulation because it can't think fast enough to keep up with the game. And does the same thing, detects the pill, detects the viruses in their current state, calculates what it thinks is the best operation, and then drops the pill. New pill does the same thing. So the way that this works, I guess I'll use my mouse as a pointer for people online. The way that this works is I have it set to find this empty area of the screen where the pill initially drops in, and I tell it to observe. In fact, you can see that right here. Pill drop dot observe ever. And the only thing that I'm listening for is changes to that area. So I told it when that area changes, when the pill drop area changes, perform the operations listed in process pill. So what process pill does, I'm just going to scroll up here. Process pill, the first thing it does that's relevant is it detects what pill it is. So it does that by calling this get this pill function, and we'll go look at that real quick. Get this pill, get this pill, get this pill, get this pill. Right here, get this pill. So I have an array of two blank things, and then it's going to look inside of another list for names and images inside this array called pills. So inside that array of pills, I have a name and then images. So the images that I'm looking for is I took a screenshot of the left half of a blue pill and a screenshot of the right half of a blue pill, and then a screenshot of the left half of a red pill, right half of a right pill, left half of a yellow pill, right half of yellow pill. Thankfully, there are only 3 colors in Dr. Mario for the NES. But with those 3 colors, you can see that the algorithm is not perfect. With those 3 colors, where was I? I was in get pill, which is somewhere up. get this pill. So I'm just searching for each half. And when I find a half that matches, I store that half inside this pill array, and then I return that pill array to the calling function, which is down here. So now I have my pill. I check to see, is there really no pill? If there's really no pill, then this is a false positive. Continue your normal life. If it was a good pill, then it tries to find all the viruses. And I'll bet you can guess the algorithm that I use for finding the viruses. It's the exact same thing. Now, the only thing that's different about finding the viruses is that if you watch the game when it's unpaused, is that the viruses are actually animated. And so the frame that I will have for that virus depends on which frame it actually gets paused on. So I actually have in my list of, I have 2 images. Thankfully, in Dr. Mario, they only use 2 frames to animate the bugs. Now, if the frames were similar enough to each other, then I probably wouldn't have to worry about that. But what I found is that when I turned the similarity slider down, it started matching the other colors of viruses. So question?
You could also take 2 different frames and average them together. That way, your similarity would match.
It's not a bad idea. Yes?
So you mentioned that it's somewhat color agnostic. Can
Yes.
you make it like match on color more instead of just shape? Because you have it on exact.
The only way you can make it match on color is by using exact. Reliably. Right, so then I have a simple algorithm. Actually, you can kind of see what the algorithm does. It finds all the viruses in the bottle, and then it floats all of those values to the top because it's just interested on, if I drop this pill, what's going to happen? And then it has a simple heuristic. If the colors match, it scores a point. If the colors mismatch, then it subtracts half a point. And if it's empty, then it doesn't do anything. So it uses that to calculate what it believes to be the best move, and it moves the pill accordingly. So that's a very simple algorithm, and you can see it's not perfect. And it looks like the game, oh, it's because I'm clicking on stuff. I probably, that's the other thing. If I'm sending key commands, the key commands are going to go to whatever application has focus. So at some point, I probably clicked on something and I messed up the algorithm. So we'll just unpause it, see if it keeps going. Hey, look at that. Where's it going to drop that pill? I wonder. Probably right where it's at.
Hopefully.
Now, what we should see when it gets to the next pill, it should move it over 1, and which should kill the blue guy. But then when it gets to the yellow pill, it's going to do something dumb. The way that I wrote it, it's only looking for viruses inside the bottle. Yeah, that's part of the what's coming up next. Now, when it processes this yellow pill, we'll see it does something stupid. If a human player probably wouldn't make this mistake, right? They would rotate the pill and drop it on that dude, or they would just drop it on that dude. If they're going for points, they rotate it.
But it only sees one orientation.
Right. It only sees one orientation. Of course, we can code it to calculate a heuristic for the rotated thing as well, but I didn't do that. Oh, look! He might actually win this game. I've never seen it beat a level. I've actually never seen it finish a thing because I was working on this like right before people got here. So this is really exciting for me. Of course, it's really slow, and I should probably fill this time with more information. I paused it, and I'm going to move my presentation over here, and then I'm going to unpause it while I go over this next slide here. Yeah, pretty smart. Uh-oh, it's not going to detect that pill. That's okay. It's going to detect a false positive, and it's going to continue processing because it's only looking for pills right here. So it's going to see that there's no pill and think that it was a false positive and continue like normal. Okay, so cheat sheet on this slide. This is just kind of a list of the most common functions that you would use. Oh, you know what? I clicked again. I got to remember not to do that. Well, it's broken. I broke it. Forget about it. Game over. Never going to beat Dr. Mario. So these are some of the most common things. If you use find, it'll return one single match. If you use find all, it'll return an iterator. Wait waits for something to appear on the screen. Exists will return true or false if it finds something on the screen. Wait vanish will wait until something on the screen has gone away. These are pretty obvious, right? One that's maybe less obvious is capture. This will actually let you, during runtime, let you select a region on the screen, which can be useful so that you don't have to, like in Minesweeper, I told it to find the smiley face and then find the game board according to where the smiley face was. I could have used capture and then just highlighted the game board, and it could work that way as well. When you have a match, you can observe it, you can stop observing it. Some of the things you can listen for is when something appears, when something vanishes, when something changes. And all of these things, those callbacks operate in a separate thread, which is important to know. You can use these operations to modify a region that you have. So you can grow a region, you can look nearby a region, you can look above, below, to the left, or to the right of a region. And these are some of the actions you can perform. You can click, you can double click, you can right click, you can tell it to type, you can tell it to hover, you can tell it to drag and drop. There's a ton more that you can tell it to do. Like you can actually tell it to move the mouse and push the mouse button down and wait 4 seconds and release the mouse button. You can tell it to do the same thing with the keyboard. You can tell it to press a key, wait 3 seconds, and then release a key. In fact, that's what I do in Dr. Mario. After I figure out where I want the pill to go, I tell it to push down. That's what's wrong. I tell it to push down, and then I tell it to hold down until it sees a new pill. And when it sees a new pill is when it finally releases the down key. We're back up. We're back up and running, guys. It's serious business. Maybe. Maybe not. Oh, okay. Well, anyway, I have to try to catch it like while it's doing a thing. Anyway, so where are my slides? Here, there. I'm clicking, it doesn't work. Okay, so that's just kind of a quick cheat sheet. Oh, it's pressing keys on my presentation. Right? I have to kill it. So when you're not running in the IDE, the Alt-Shift-C thing doesn't work. You have to kill it yourself. Of course, you have access to all of Python and you have access to all of Java. So if you want to add a shell hook to capture some hotkey for canceling your script, you can do that. I didn't do that. You should do that. Okay, where was I? Tips. Okay, so some tips. And I think this is the probably end. Yeah. So when you're doing things, you should try to focus on primarily doing idempotent changes. So if you're having it type in a text box, don't have it click on the text box and just start typing. Have it select all of the text in the text box and then start typing. Because you don't know what's going to be in there. Maybe you think, oh, they're all going to be blank. Well, guess what? They're not all going to be blank. Having used this tool in a production environment at a hospital system, I can tell you it's important that you make idempotent changes. And don't rely on things like, I see a lot of people when they want to select all, they use their mouse, they click towards the end and then they drag it to the left. They're like, okay, I got the whole address there. Don't do that. Use keyboard commands. Control-A selects all, or press the home key and then Shift-Control-End key to get everything. That would be much better. Another thing that you'll find is that, right, Control-Home and then Control-Shift-End to select everything. Another thing that you'll find is that your computer's timing doesn't work exactly the same way that you probably thought it did. And you'll probably end up adding some random sleep calls in order to make sure that it actually processes when you need it to. Word of advice, add a comment every time you add one of those sleep calls, because when you go and look at your code later and you're trying to clean it up because you need it to run really fast and it's not doing that, you're going to start deleting those sleep calls and then you're going to hate yourself. And I love you, so you should love you. So add comments to your sleep commands. Keyboard navigation versus mouse navigation for dropdowns. I talked about that already. Exists is actually a really cool feature to use. You can use it to find something, but a lot of times before I knew that function existed, I would do like if exists some image, then find that image, and oh, don't find it, but click on it. So this is actually redundant. What this is going to do, this is going to tell the computer vision engine to search for this image and then return true. And then it tells it to search for this image again and then to click on it. That's redundant. You can actually do this in one thing. You can use this get last match. Is really handy. Make it go a little bit faster. Alt-Shift-C will kill your script if you're using the IDE. If you're not using the IDE, then write your own. Sikuli-i runs in interactive mode, and then you can use exec file to load your script, which is really handy if you're trying to develop rapidly and you don't want to wait for the JVM to fire up. And then if you're working with specific programs, they have this special app class, which is really handy for launching applications and bringing up active windows of existing applications. Instead of like looking for the right button in your taskbar or whatever, you can just tell it to find the binary, the window that matches the binary that you're looking for. So that's really handy. Okay, it's 8:30. I wanted to end this presentation. I know that like that was really fast, and I really just like scratched the surface of what you can do with Sikuli. But hopefully that gave you some ideas. On my Bitbucket account, I have this presentation. I also have the code for Dr. Mario and for the Minesweeper game. So if anybody here is hanging out, then I would invite you to download that code. Hopefully you have Sikuli running and you're, did it finish compiling?
Yeah.
Sweet.
It's all there. I mean, I like working with the Hello World version, yeah, so it didn't run.
Oh, we can, maybe, I doubt I can help, but I could try. So yeah, so I would invite you to go and download the code, and maybe we can see who can write the best Dr. Mario bot in the room. Do you guys have any questions at this time? Yes?
Do you know what the performance bottleneck is? Just like, for instance, is it maxing out your CPU when it's waiting? You're waiting on
The performance bottleneck is definitely on matching. It's the computer vision module is the slowest part by far. In fact, that's really all that there is. Like everything else is speedy. Some things that you, oh, that's a good question actually. One thing that you can do to speed up the program, all of those things in my cheat sheet that I lost, all of these things, you can just call those functions and they'll work. By default, they're scoped to the entire screen. So if you tell it to find a virus, it's going to search the entire screen for a virus. And that obviously is going to be a much slower operation than just searching inside this pill bottle. So if you look at my code, I'm pretty sure I did that right. Find viruses, so I find the top of the bottle, and then I'm grabbing the area 256 pixels below the top of the bottle, and I'm only looking for find all in the bottle area. So that limits the computer vision search to just that area, which will speed it up significantly. Another thing that you can also do, you can tell it to, you saw when I did the WordPress demo that it was like actually moving the mouse to the locations. You can change that. You can set the speed of the mouse. You can set it to 0 so that it just snaps to the spot and clicks on it, which is really good for some things, but completely breaks other things, which is kind of weird. The other thing that breaks when you wouldn't think that it would is typing. You cannot control the type speed. So if you give it a thing that just says type hello world, it's going to type that, and it types it pretty fast. What I found is like on this emulator that I'm running to play Dr. Mario, I tell it to press the right arrow key 3 times to move the pill 3 times to the right. Well, the way that this emulator works is it's pulling for keyboard input instead of doing like event-based keyboard input. So if Sikuli doesn't press the arrow key at the same time that the program is actually pulling for the state of the arrow key, then it completely misses that keystroke, which actually happened a lot, like 30% of the time, which is crazy. So to work around that, what I had to do is I wrote just a little helper function right here that presses the key down, waits for 0.02 of a second, and then releases the key, and then waits for about 1/4 of a second before it processes the next keystroke. So that's kind of a weird caveat that you might run into. There's a lot of little things that you might run into. Don't be surprised by those things. They're usually pretty easy to figure out what you need to do. Yes?
So if you had something that, could you like paste it instead of typing it? If
You can, yes. There is a paste function for that. It's called paste. Yes. If you want to, there's also, oh, I didn't talk about that. It can also do, oh, look, it's right there. It's at the bottom. That's why I missed it. Oh, I missed this too. If you want to do key modifiers, you can do that. It's just key modifier dot. So you use type, you give it the key. Those parentheses shouldn't be there. That's a constant. Key, you can either give it a string of letters and numbers that you want it to type in characters, or you can, there's some constants to find like the enter key, up, down, left, right, home, end, and then key modifiers are in there as well. So shift, meta, control, caps lock. probably in there. I don't know where Jacob went. And then there's also text and paste. So it uses Tesseract for OCR. So you can actually find a region on the screen and have it extract the text from that region. It's not reliable though. I wouldn't recommend it for anything that's important. And then, yeah, and then there's the paste. So if you had something in the clipboard, you could just have it paste what's in the clipboard, which works kind of okay. Actually, when I was using this, whatever year that was, years ago, it's probably better now. But when I was using it before, the paste method wasn't reliable for me. What I ended up doing is actually using Java to extract the contents of the clipboard and then type the contents of the clipboard. So it might work. Your mileage may vary. I don't know. It's been like 4 or 5 years, and there's been some changes.
For in your medical example, we're using just normal Java or Python file IO to get all the data.
Python, yeah.
Okay.
Yes.
And did you say early on that one of the things that won't capture the enter key, have to capture mouse clicks? Or?
I think that,
you
that was specific to that piece of medical software.
Oh yeah, when I was showing that example, the people that wrote that software, I shouldn't like talk badly about people who write software, but it was not great. That's the nicest way I think I can phrase that. It was not great. Like there were things that you had to double click, like, you know, you could select it with the mouse, but like entering wouldn't open it. You had to double click on it. That program was crap, which is one of the nice things. Was not the greatest. Dang it. It was crap. Let's just be honest. It was crap. So having like an automated system was actually really, really handy. And I ended up developing like an entire framework around Sikuli for automating several different components of that system, because that was basically my job for like 2.5 years. And they were paying people a lot of money to do monkey work. So I was able to do that monkey work at 500% efficiency while I was out having dinner. It's technology. Okay. Any other questions? Yes.
I'll send you a bot if you send me some screenshots of your bank's building setup.
Probably not. Anybody else? There's lots of stuff online on the Sikuli website. The documentation is pretty decent. We definitely recommend you guys check it out. It's a great tool to have in your tool belt because you'll never know when it can come in handy. Like I said, I used it at work for a couple of years and it saved me hours. I don't even think I could calculate the number of hours that it saved me running it in virtual machines. But I think that's all I got. So thanks everybody for coming.